Hello students and welcome to my channel Maths Hub. So in this video, I will be focusing on analytic functions. So before this, I have told you about the concept of limit, continuity and differentiability, right? So now what are analytic functions? So let's go by the definition. We say that a function fz is said to be analytic in a domain D if f of z is defined and is differentiable at every point of D. So in the last video, if you have seen, you must be knowing the definition of differentiability. And if you have not seen it, please do watch it before you check this video, right? So we are saying that suppose this is a domain D. What is a domain? It is basically a set of points, right? So you can see that there will be a set of infinite points here. So in this domain, if the function f of z is defined and is differentiable at every point of D, so at all these points, if the function is differentiable, then we say that the function is analytic, right? That means analyticity is much more than differentiability. Differentiability we just talk about at a single point, but in analytics we talk about only. So in analyticity, we are talking about differentiability at every point of a domain D, right? So that means a function f of z is said to be analytic at the point z equal to z naught if f of z is differentiable in some neighborhood of z naught. So if we are talking about the differentiability, analyticity at a point z naught, suppose let's talk about this domain and suppose this is the point z naught. So if I'm talking about analyticity at this point z naught, I have to check all its neighborhood, right? So its neighborhood will also contain many points, infinite points. So if at all the points the function is differentiable, then we say that the function is a analytic function at the point z equal to z naught, right? Okay. So now regular and holomorphic are also used as synonyms with the term analytic. So that means in some books you might also find these terms, that is regular and holomorphic. So they are the synonyms that are used with the term analytic, right? So now let us talk about singular points. Now the points in the domain of fz where fz is not differentiable are called singular points or the singularities of fz. So it is not necessary now that in the domain D, the function will be differentiable at all the points. So wherever the function is not differentiable, that point is called a singular point or the singularity of the function f of z, right? Now what are entire function? A function which is analytic everywhere. So that means whatever domain is mentioned to you, if the function is analytic everywhere, then we say that it is an entire function. So what are the examples of entire functions? Polynomials and rational functions are all entire functions. So any polynomial you take, all rational functions, they are all entire functions, right? So now let us understand this important relationship. So we start from the inner circle, that is the orange circle. We have an entire function. If it is entire, it will be analytic, right? That means all analytic functions are entire function means all everywhere which is analytic, right? Then if a function is analytic, it will be 100% differentiable. If a function is differentiable, it will be 100% continuous, right? But if we go the other way around, so if we move from continuous to differentiability, the function may be continuous, but it may not be differentiable. A function may be differentiable, but it may not be analytic. A function may be analytic, but it may not be entire, right? So that means whenever we go from inside to outside, all the relations hold. But whenever we move from the outer circle to the inner circle, the relations may not hold, right? So this will help you to answer many questions, right? Okay. So now let us move on to another important relationship that is known as the Cauchy-Riemann equations. Now what are Cauchy-Riemann equations? So the necessary and the sufficient conditions for a function to be analytic are, so if we have any function, any general function f equal to u plus iota v, and how do we check for analytic? Obviously, it is not easy for us to check differentiability at every point, right? Because there are infinite points. So there is another definition to check analyticity. So the first condition is that the four partial derivatives, that is del u by del x, del u by del y, del v by del x, and del v by del y, they should be continuous. And the second relationship is that all these four partial derivatives, they must satisfy the Cauchy-Riemann equations. So what are the Cauchy-Riemann equations? There are two relations. The first relation is del u by del x is equal to del v by del y. And second is del u by del y is equal to minus del v by del x. So sometimes these equations are also known as CR equations in short, right? So C stands for Cauchy and R stands for Riemann. So these are the two relationships that the equations u and v must satisfy, right? Okay. So the Cauchy-Riemann equations, very, very important, and many questions are based on Cauchy-Riemann equations, right? So what are the immediate conclusions from this Cauchy-Riemann equations? If the function is analytic in a domain D, then u and v will always satisfy the CR equations at all the points of the domain D. CR equations are necessary but not sufficient conditions for a function to be analytic, right? That means when we have all the four partial derivatives continuous, only then we can say that the function will be analytic, right? Only proving the CR equations are not sufficient to check whether a function is analytic or not. CR equations are sufficient if the partial derivatives are continuous, right? So derivative of f can be calculated as, so you should also remember this derivative formula. F dash z is ux plus iota times vx. So what is ux? It is curl u by curl x plus iota times curl v by curl x, right? Okay. So you can convert this either in terms of x or in terms of y using the Cauchy-Riemann equations. So we know that curl u by curl x is equal to curl v by curl y, and curl v by curl x is equal to minus curl u by curl y. So when you replace these two values in terms of partial derivatives with respect to y, we get the second formula, right? Okay. So you can also convert it. Now here we are having a mixed v and u. So you can also convert this formula purely in terms of u or purely in terms of v. So ux, if you keep it as it is, you can convert vx. Vx is minus del u by del y. So it will become ux minus iota times uy. And similarly, you can also write it as vy plus iota times vx. So according to the conditions of the problem, you can convert your equation, right? Let's understand the exercise. Determine a, b, c, and d so that the function f of z is equal to x squared plus axy plus by squared plus iota times cx squared plus dxy plus y squared is analytic. So first of all, we compare this equation with u plus iota v and identify u and v. So u is x squared plus axy plus by square and v is cx squared plus dxy plus y square, right? So from here, let's calculate curl u by curl x. So curl u by curl x is 2x plus ay, and curl u by curl y would be, it would be ax plus 2by, right? Similarly, let's calculate curl v by curl x. So curl v by curl x would be 2cx plus dy, and curl v by curl y would be dx plus 2y. So now the first CR equation says curl u by curl x is equal to curl v by curl y. So curl u by curl x is 2x plus ay, and curl v by curl y is dx plus 2y. So when you compare them, d is equal to 2 and a is equal to 2, right? Similarly, let's check out the second relation. The second relation is curl u by curl y is equal to minus curl v by curl x. So what is curl u by curl y? It is ax plus 2by. And what is curl v by curl minus curl v by curl x? It is minus 2cx minus dy. When you compare the coefficients, you will get a is equal to minus 2c and 2b is equal to minus d. So if a is 2, c will become minus 1, and if d is equal to 2, then b will become minus 1, right? So these are the values of a, b, c, and d when the function is analytic, right? So I hope you understood this question. Okay. So now let's move on to the next question. Show that the function f of z is e to the power x cos y plus iota sin y is holomorphic, and find its derivatives. So how to do this question? So again, this is compare it with u plus iota v. So you will very easily get the values of u and v. So u is e raised to power x into cos y, and b is equal to e raised to power x into sin y, right? So we have to check it is holomorphic. So holomorphic means we have to check for analytic functions, right? So let's calculate curl u by curl x. So it is e raised to power x cos y. And what is curl u by curl y? It is minus e raised to power x sin y, right? Now, what is curl v by curl x? It would be e to the power x sin y. And what is curl v by curl y? It is e to the power x cos y. So you can see that all the four partial derivatives, they are existing and they are continuous because they are functions of exponential and trigonometry, right? So now let's see whether curl u by curl x is equal to curl v by curl y. Yes, it is. And similarly, you can also see that curl u by curl y is equal to minus curl v by curl x, right? So both the equations are satisfied and hence it is a analytic function, right? Now, the second thing that we need to check is f dash z. So what is f dash z? It is curl u by curl x plus iota times curl v by curl x. So curl u by curl x we have already calculated. It is e raised to power x into cos y plus iota times what is curl v by curl x? It is e raised to power x into sin y. So we get e raised to power x common. We will have cos y plus iota sin y. And what is cos y plus iota sin y? So you must have done this relationship in plus 2. E raised to power iota theta is cos theta plus iota sin theta, right? De Morbi's theorem. So from there, we get this relationship that this is e raised to power iota y. So this is e raised to power x plus iota y. And what is x plus iota y? It is e raised to power z. So what is the derivative? The derivative is equal to e raised to power z, right? Okay. So now let's check the next question. Use Cauchy-Riemann equations to show that fz is equal to e raised to power z is differentiable. So if you remember that circle relationship, if a function is analytic, it will be 100% differentiable. So we have to check that f of z is equal to e raised to power z is differentiable or not. So let us write e raised to power z as e raised to power x plus iota y. So this is e raised to power x into e raised to power iota y. So I can write this as e raised to power x into e raised to power iota y is cos y plus iota sin y. So we get e to the power x cos y is the real part of this function, and e raised to power x into sin y is the imaginary part of this function, right? So let's calculate curl u by curl x. So what is curl u by curl x? It would be e to the power x into cos y. And what is curl v by curl y? Curl v by curl y would be e raised to power x into cos y. So you can see curl u by curl x and curl v by curl y are same. Similarly, let's calculate curl u by curl y. So it will be minus e to the power x into sin y. And what is curl v by curl x? It would be e to the power x into sin y. So you can see that curl u by curl y is equal to minus curl v by curl x. So the Cauchy-Riemann equations are satisfied. CR equations are satisfied, right? If the CR equations are satisfied and the functions, the derivatives are continuous, that means f of z is analytic. And if f of z is analytic, then by that relationship, you will get that f of z is 100% differentiable also, right? So I hope this question is clear to everyone, right? Okay. So let's move on to the next question. The next question says, use Cauchy-Riemann equations to show that f of z is equal to z bar is not differentiable. So f of z is equal to z bar. What is z bar? X minus iota y, right? So when you compare it with u plus iota v, u will come out to be x and v will come out to be minus y. So what is curl u by curl x? It would be 1 What is curl u by curl y? It would be 0. Similarly, what is curl v by curl x? 0. What is curl v by curl y? Minus 1. So is curl u by curl x equal to curl v by curl y? No. So it's not analytic. If it is not analytic, it will not be differentiable also, right? Okay. So now let's talk about the CR equations in polar coordinates. So far we were discussing about the Cartesian system, right? So in polar coordinates, we will always write z is equal to r e raised to power iota theta. Why we will write this as r into e raised to power iota theta? So according to polar system, x is equal to r cos theta and y is equal to r sin theta. So when you take out r common from here, we will get cos theta plus iota sin theta. And you have already done this relationship in your junior classes. So this is e raised to power iota theta. So that means whenever we convert Cartesian to polar, we will always write z as r e raised to power iota theta, right? So we will express the real and imaginary parts of the function as r and theta, and then we will get some functions u and v in terms of r and theta after separating the real and the imaginary parts. So the CR equations, they will become curl u by curl r is equal to 1 by r curl v by curl theta, and curl v by curl r is equal to minus 1 by r curl u by curl theta. So you should remember these two CR equations in polar coordinates, right? Curl u by curl r is 1 by r curl v by curl theta, and curl v by curl r is equal to minus 1 by r curl u by curl theta, right? So now let's check this question. If w is equal to log z, determine whether w is analytic, right? So w is equal to log z, so let us write z as r into e raised to power iota theta. So what is log mn? It is log m plus log n, log e raised to power iota theta. So that will become log of r plus log and exponential will get cancelled and it will become iota theta. So u will be log r and v will be theta, right? So let's calculate curl u by curl r. So what is curl u by curl r? It is 1 by r. And what is curl u by curl theta? It is 0. Similarly, curl v by curl r is 0. And what is curl v by curl theta? It is 1. So we need to check the first relationship. Is curl u by curl r equal to 1 by r times curl v by curl theta? Yes. And similarly, is curl v by curl r is equal to minus 1 by r curl u by curl theta? Both are 0. So yes. So this shows that w is analytic, right? The CR equations are satisfied in the polar coordinate system. Done? Okay. So now you need to check these progress questions. So the function f of z is x plus iota y, xy plus iota y. So you need to mark the correct options. I'm giving you the answer, but you need to check why it is the correct option, right? So your answer will be that function is continuous everywhere and it is not analytic, right? The second progress question that you need to check is, for the function f of z is equal to x upon x squared plus y squared minus iota y upon x squared plus y squared. Again, you need to check the correct options. The correct option will be coming out to be fz is analytic in the domain except at z equal to 0. So do practice these questions and let me know in the comment section whether you were able to solve it, right? So thank you so much for listening to me. And those of you who have liked the video, just hit the like button. And those of you who haven't subscribed my channel, do subscribe my channel to get the latest updated video. Believe in yourself and you will definitely succeed. Have a nice day.